modern technologies, advanced MOSFET device structure, device isolation, CU interconnections under lower resistivity, higher melting point, lower thermal expansion, lower electromigration. Classical way metallization, metal deposition. Here, metal deposition, oxide. Okay, already we have seen this is the modern technology. Okay. Etching of all metals. This metal removing from here and from here and from here. Metal. Okay. Remove. And then oxide gap fill plus oxide CMP. Then oxide gap fill here, 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 here. Oxide gap fill, oxide CMP. Okay. Both same. Then in this is a classical AL metallization. Damascene CU metallization. Etching outside of trenches. Here, etching. Here, okay. Then metal deposition. Full metal. This. Here, metal CMP. That is here, no? That one remove. This part. Remove. Mixed signal technologies modules. CMOS process options for each IC applications. 2 versus triple well. Shallow trench isolation, STI. Shallow trench isolation. Here, P plus. Yes. Source, drain, N plus. Source, P1. And then gate, N minus. Okay. This one N plus. Here, metal. Here, base. P substrate. P well, N well. Oh. Okay. Here, B base. Here, this is B well, say N well, but here only change. Here, P plus, P minus, P plus, N plus. Change state, source, and then D N well. Okay, this one, D N well. P well, okay, here N well. Here. But here P plus, P minus, P plus, N plus. Here N plus, N minus, N plus, P plus. Here total this pool, here pool, this pool, N1. Okay, N1. This is P subset. Here this connection according to this gate, source, drain, ground. Here this one P1. Okay. P1. Okay. This one. Then here N1. In this N1, here drain, edge, gate, source. Okay. And then this N1 here, this email here, and then here source get train. Here this gate here, this one, this train here, source here. Okay, that this one is dependent. This equal, this is this and not this. Get bootstrapping in SC circuits. Get bootstrapping in SC circuits input sample charge pumps. Isolation against substrate noise. Off circuit. Get bootstrapping short circuits input samples SC circuit. Okay. Input samples charge pumps. DC. Okay. Yeah. Mixed signal modules. CMOS process option for each IC application. Twin SS triple well. Twin SS triple well. Several MOSFET threshold voltage families. Several MOSFET threshold voltage families. Family LP, LV, TH, VTN voltage V 0.50, 0.33, 0.70, and then here VTB threshold in P minus 0.55, minus 0.33, minus 0.63. Here in N side threshold 0.50, 0.33 plus 70. Here all are minus negative value. Here positive. Purpose plus 1.8 volt low leakage core. Here low supply voltage plus 3.3 volt IO interface. Okay. And then example 0.18 micrometer IP6M CMOS technology. Mixed signal technology modules. In this mixed signal technology modules, CMOS process options for each IC application. Twin versus triple well, several MOSFET threshold voltage families, metal insulator, metal insulator, metal and French linear capacitors, high resistance polysilicon, high resistance polysilicon, PO. Here also metal insulator, metal high resistance polysilicon, linear and low DC resistors, thick top metal for high RF inductors. Here triple capacitor. 1, 2, 3. 1, 2, 3. Here 4M French capacitor. 1, 2, 3, 4. 4M. Differential inductor. Differential inductor. This length with this is in between this D. Here Xn differential inductor. Ground plate is the connection through. Okay. This one continuously coil. Okay. Mixed signal technology modules. CMOS process option for each applications. Once again remind. TMSS, triple well, several MOSFET technology voltage families, metal insulated metal, and French linear capacitors, high resistance polysilicon, linear and low DC resistors, thick top metal for high Q RF indicators, inductors, linear varactors for continuous RF tuning, high voltage and LDMOS transistor for power management, lateral and vertical bipolar transistor for band gap references, anti-reflective coating, optimum doping profiles for CMOS image sensors, CMAS, CAS, C for CMOS image, I for image, S for sensors. And the non-voltaic memory, NVM, N for non, V for voltaic, M for memory, for chip ID configuration and tuning. Many modules equal to higher mask slash divided by process plus difficult circuit design migration. Okay. Hybrid packaging alternatives. Classic wire bonding approach. Wire bonding. Okay. Sensor, CMOS package, PCB package. This is the what they told. Classic wire bonding approach. Monolithic solution, signal integrity protection. Monolithic solution, signal integrity protection. Sensors need to be CMOS compatible. Sensor, this is the sensor. Needs CMOS compatible. Okay, compatible. Area cost, wire bonding cost for large areas. Wire bonding cost for large wire bond. This is wire bond. Okay, bin package sensor, CMOS, wire package. Wire bonding cost, wire bonding. Hybrid packaging alternatives. Classic wire bonding approach. Bump bonding flip chip here. Here sensor, CMOS, wire bond, package PCB. Okay, this is package PCB. Monolithic solution, signal integrity protection. Sensors need to be CMOS compatible. Okay, compatible. Sensor needs compatible. Area cost, and then wire bonding cost for large areas. Wire bonding. This is the wire bonding with the PCB. Here, this is the classic wire bonding approach. Here, pump bonding flip chip. Here, heterogeneous sensor, CMOS technologies. Heterogeneous sensor, CMOS technology. This is CMOS technology. Sensor area can be reused for circuit.